that way you can recover, you can copy that data back to your container when you're recovering, and you get your data back.
Okay.
Any other
No, Ravi.
cool. So we'll continue. Give me one moment. Okay. Let me share my screen. Yeah. So yesterday we discussed about your env instruction, your add, copy, uh, entry point, and then your volume instruction. We also looked at how you can build your images, right? So we'll continuing from there. The next instruction we are going to look at is your user. Now, by default, whatever the instructions that you are executing, those instruction gets executed as a root user by default. Okay, so let's say for example you're creating some file, or you're installing some packages, or you're creating a user, whatever the instructions that you are giving, by default it gets executed as a root user. Now if you want to execute any commands as a non-root user, that's where we can make use of your user instruction. So just to show you an example for this, here is my Docker file. Okay, so now let's say I'll create, let me run an one instruction, and I'll create one file, and let's simply call it as index.html file. Now this one, if you see by default, okay, let it be. Now let me save this, or you know what? Let me do this. Let me also. Now until here, all of these instructions will get executed as a user by default. Now let's say I want to create one user. Okay, so here I'm going to run this command which will create one user for me. So am I audible to you people?
Yes, Ravi. I'm able to follow.
Yes, Ravi.
Okay, looks like so now I'll use this user add instruction. So I'm going to create one user over here. So ms bin bash is the interpreter for this, and let's call this as Docker user. So first, using the root user, we are creating one user. Okay, and then I'm going to set the user. So now I'm telling my Docker that change your user as this user, and then any subsequent instructions I will run will get executed as this user. Until here, by default, your instructions will get executed as a root user. Once you define this user instruction, and the subsequent instructions will get executed as that user. Does that make sense?
Yes, Ravi.
Okay. So the user instruction is used to run the commands in the container with a specific user. The instruction sets the username and optionally the user group to use when running the image, and for any run cmd and entry point instructions that follow it in the Docker file. So all the subsequent instructions after you set the user, the subsequent instructions will get executed as that user. Okay. The next instruction you have is a work_dir. The work_dir is used to set your working directory. Again, by default, any instructions that you run gets executed in the root directory. So think of it as your C drive. By default, it gets executed in the root directory. But if you want to set a working directory for your subsequent instructions, we can make use of your workdir for that. So the workdir instruction is used to set the working directory for any run, CMD, entry point, copy, and add instructions that follow in the Docker file. So if the work directory does not exist, it will be created even if it's not used in the subsequent Docker file instruction. And the work directory instruction can be used multiple times in a Docker file. So like this, you can simply say work dir, and then you can specify the path which one you want to set as a working directory. And then the subsequent instructions that you will run will get executed in that particular directory only. Now, here I have one touch command. Now this one will get executed in the root directory. Here also I have one, and this will also will get executed in the root directory. Let me, so that it won't give me a duplicate issue. Now here I have set my working directory. All right. Now let me run this. Now what will happen is this instruction will get executed in this directory. So if you want to set your working directory for your subsequent instructions, we can make use of your workdir command. Questions?
No, Ravi.
No, Ravi.
Okay. All right, so let's build this and see what it will do. So Docker build -t, let's say custom image version 3.0 and then dot. So this will start building the image for us. So in this case, I have total 19 instructions, and I'm getting a permission denied error. So we'll have to change the Docker file. So, because it is executing it as a Docker user, it is giving me a permission denied error. So let me move this to the temp folder. Yes, I'm going to create this in the temp folder. Again, done. So total we had 19 instructions, and all the instructions got executed. And here is the new image that we have created. So let's start a container out of this. So Docker run -dit version 3.0. This should start a new container for me, and let's connect to this container. Now before that, this is the Docker file we have, right? Now let's connect to the container over here. So I'll take the container ID and we'll say Docker exec. Then we'll use vim bash. We'll connect the container. Now if you see here, this is because of this particular command. So I've set my log into the container, it will log into the working directory. And so this particular command, I should be able to see the file. You can see here. No, hold on. Where's this file? HTML. This file. Okay, let's take it step by step. So starting from here, okay, so touch index.html file. So there's my index.html file, which was created as a root user. Okay. Then what I did, I have set my user, and then I've created this file in this particular location. So let's go to that temp folder here. And here you can see the file, and also you can see the user. So if you want to set your users to execute your commands, we make use of your Docker, sorry, the user instruction. Then I set my working directory, did not create my file. User root run touch Working directory. Oh, I should have given a slash here. Okay, I should have given a slash. So in that case, I should have given a slash. So here I should have given a slash. It would have understood. Okay. But does this make sense?
I mean, we created like, which file, Ravi? Like, I missed it. The working directory which we created.
So no, see, we are just setting the working directory, telling that, hey, the subsequent instructions I want you to execute in this directory. By default, it gets executed in the root directory. So your root would be this one by default. So for example, here if you see, I gave this particular command, run touch, and then the file name. So if you see, nowhere I've given the path or anything. By default, it executed it in the root directory by default.
Okay.
If you want the instructions to be executed in a particular path, then you can either give the entire path or you can set your working directory like this using this workdir command. You can set your working directory so that the subsequent instructions will get executed in that particular directory only.
So if you have to change the working directory, do you have to edit the Docker file, or is there any command, cd command, and change the working directory? I mean,
No, I mean,
that
once you're connected to the container, you can change it. See, by
okay.
default, when you connect to the container, this will be your working directory. After that, you can do a CD, you can move around the file system, you can go to anything, anywhere you want, you can do it. But by default, it will go to your var www.html. That's all.
Okay, got it. But if in case if I want to change the default that set directory the Docker file, so if I want to change, how do I change it?
Again, you will have to do it from the Docker file. So you'll have to again add one
Edit
more
the
workdir instruction. Yeah. So you'll have to again edit this Docker file and again create a new image out of it.
Okay, got it.
The next instruction we have is your ARG instruction. We have already discussed a bit about it. We'll be going to talk a bit more on this. So ARG is another way that you can set your variable. So both your env and ARG are used to set your variables. Okay, so ARG is used to set your dynamic variables and env is used to set your static variables. Okay, so one moment. Yeah, so env I've already shown you the example. So here if you look at the Docker file, this is your env instruction. Now we can also make use of your ARG instruction to set your variables. However, the values for it, you can change it whenever you want. Okay, that's the point of it. So the ARG instruction defines a variable that users can pass at build time to the builder with the Docker build command by using this flag. So if you want to override the value, you can override it by using this argument when you're building the image. So how do you pass this? So if a user specifies a build argument that was not defined in the Docker file, the build outputs a warning. And a Docker file may include one or more ARG instructions. So this is how you will be defining your ARG instruction. So with this, you're only going to declare the variables. That's all. You won't be passing the values. The values for this will be passed when you are building the image. Okay, whenever you want to when you run the Docker build command, that is when you will be passing the variable values to this. So here, let's say what I can do is I can set this to ARG, and let's call this as folder name or file name, whatever you want you can use. That's up to you. And then I'm going to call that variable over here. So we will call this as $folder name. Okay. Now if you see, nowhere I'm passing the value. Okay. So the value for this will be defined outside the Docker file. when we are passing the build instruction, the Docker build command, we can pass the value to this. Let me know if I'm not audible to you, because looks like there's a network issue. So Docker build -p, and let's say this will be custom image version 4.0, and then we will be passing your like this. We will be passing the argument. Okay, so we will say --build--arg. Okay, so we're telling build the arg variable, the variable name, and the value, whatever the value that you want to set, you can pass this. So now what will happen here is your Docker will take the value, the variable that we have defined. Okay, it will replace that with the value that we are passing over here. Okay, so this arg, you can see it is done. So that's that's the point of your arg. Arg is also used to define your variables. However, the values can be dynamic. You can change it whenever you want, unlike your env, which is static. Questions?
No, Ravi.
Talk about on build can be confusing. The last instruction we have is your health check. Now, see, there are two things when we talk about your container. The one is the container itself, and the second is your application that you're running inside the container. So let's say, for example, I will start one. So let's say -dit -p, and let's say Nginx. Just for the sake of example, so I've started a new container. Now Nginx is an application, right? So here my container is created, but how do we know whether the application inside this container is running or not? I mean, now this is telling me that, hey, the container is up and running, but what about the application? How do we know the application inside this container is running successfully or not? So that's where we can make use of your health check instruction. So health check instructions can be used to validate the health of your applications running inside the container. So in addition to this status, it will also tell you whether your application inside the container is successful or not. So the health check instruction tells Docker how to a container to check that it is still working. This can detect cases such as a web server that is stuck in an infinite loop and unable to handle new connections, even though the server process is still running. So you have the server process that is still running. However, it is not able to, as a user, you're not able to access the application. We can overcome those challenges. So when a container has a health check specified, it has a health status in addition to its normal status. Okay, so this is initially starting, and whenever a health check passes, it becomes healthy, and after a number of consecutive failures, it becomes unhealthy. So essentially it will tell you whether it is healthy or unhealthy. Okay, so you can put this inside your uh, Docker file. You can define a health check. So let's say health check, and then you will need to give the URL. So we are going to run a command over here. We are doing a curl over here, and then we give the endpoint. So what endpoint do you want to hit? So let's say I will give http:// and let's say google.com, just for the sake of example. Okay, so I'm giving http:// google.com, and then let's say this will be on port 80. Okay, so this will be port 80, and I'm telling this is OR condition basically. If there's any error, I'm telling you to exit it with return code -1. Okay, so I'll save this and we'll build this image once again. So Docker build -t, let's say health, and then we will also pass the build arg, which will be my folder name. Say test. Okay. So, sorry, it should be underscore. Okay, done. So now here we have created the image. Now let me start a container out of this. So we'll run docker run -d. What did we do? Yeah, that's fine. And then so this will start a new container for me. Now we will see here, in addition to the up status, in addition to this up status, it also has this health status. So initially this will be in the starting, and depending on the URL that we have given, if it is able to successfully hit that, it will change this to healthy or unhealthy. So now, in addition to telling that, hey, my container is running, I can also tell my application inside that container is also running successfully. That's where we can make use of your health check. Questions?
So if you want to see like, how many applications is running, so like, is there any command or instruction?
So see, generally the thumb rule that we follow is one container, one application.
Okay.
We don't, it is not recommended to run multiple applications inside the container. It is always one application, one container. Now,
Okay.
not like you can't run it, you can run it. But in terms of making an application highly available and fault tolerant, it is recommended to have one application in one container.
Okay, got it.
So you can see this is still starting. So, but that's basically what your health check is used for, to, basically validate whether the application inside that container is working as expected or not. So that's about the Docker file. So you can see now here it says unhealthy. This is basically my let's see if I can do this. So this is what I'm trying to do. Full.com/80. So you can see this is transitioning to HTTP, yes, right? And the health check we have given is HTTP. So it will fail. That validation is correct. We have given HTTP. Essentially, it is transitioning to HTTP, yes. And that's why it is showing it as unhealthy. But okay, that's about your Docker file. That's about all the instructions that we have in a Docker file. Now again, it's not necessary that you have to use all the instructions, but these are your very commonly used instructions we have. And whenever you want to build your custom images, this is how you do it. Questions?
No, Ravi.
No, Ravi.
Cool. The next, before that, now, I have an example that I want to show. Now, this is for a Tomcat application that I want to show. And here, if I go over, yeah, here I have all the instructions. Now, this is for a Tomcat application. So you can say I'm using the base image, the run instructions until here. I'm doing an add, I'm doing an expose, and then I'm doing the CMD instruction. Right? So let me take this and let's create our new Docker file. Right. So first I'm defining the base image. I'm using Ubuntu as my base image. Then I am updating the machine and I'm upgrading. So if there's any updates or upgrade that needs to be done, I'm doing that. Then I'm installing a couple of things. One is Java, and then I'm also installing wget. So I'm installing Java and I'm installing wget. Then what am I doing? I'm creating my user local Tomcat folder. Okay, so here I'm using the run instruction. I'm creating a directory, and this is what I'm creating. Post that, I am downloading my Tomcat. Okay, so here I am giving the URL, and then I'm telling it to store it. This is basically save as. So I'm telling it to save the downloaded file with this thing. Now only thing I'll have to do is make sure I have the right URL, because this is old version 8.5.54, and currently it is 10.1.13. So I just have to update that. Then I am unzipping the downloaded folder, the content. Then I am copying. So I'm copying everything from the unzipped folder to the user local Tomcat that I have created over here. Okay, so let me get this. Then I'm using a sample var package, so it's available. So I'm just reusing that, and I'm copying it over to my web apps folder. So here, user local Tomcat web apps folder. Then I'm exposing this on port 8080. That means I want this container to be running on port 8080. And then finally, I'm starting my Tomcat process. Does this make sense? Any questions with any of these instructions?
No, Ravi. No, sir, it's clear.
Okay. So now what we'll do is we will go ahead and build this as an image. So Docker build -t. Let's call this as Tomcat and then doc. So this will start building the Tomcat image for me, whatever the instructions I've given in that Docker file. It will start executing those instructions and it will build an image for me. So let's wait for this to complete. Oh, sorry. So I should have updated this one also. Sorry. So it is complaining about this one. Okay, so I have to update that. So this will be, well, I have to update the version number basically. So this would be 10.1.13. Okay, so let me save this. I have to do this once again. And done. So my image has been created. So Docker images. So there is my image that you have created, right? So let's start a container out of this. So Docker run -dit, and we'll do 8080, 8080, and then the image. Okay, so 8080 it says already taken. So we'll use a different port number, let's say 8081, and a new container will be created for us. Where's my Tomcat? No. Has exited. 1 minute. Let me check the logs. Could not create unrecognized options. Could be a problem with my Java, I'm thinking. Let me. Yes, it seems to be a problem with my Java. So we will go ahead and change this to default. I have to build this once again now. Let's see if that will fix the problem. Okay, no space. Give me 1 minute. I'll have to delete from the containers. Docker clone. Okay. Now let's see. Okay, now let's try this. Docker run -vit. Let's see. Okay, so there, I think yeah, it was a Java problem. So I can see there's my container running. Now, if I try accessing this, so this is running on port 8081, right? So let's quickly go. So you have to make sure you're allowing that port number. Okay, whatever port number that you are mapping, you have to make sure you're allowing that in your security group, because here we are making use of your EC2 instance, so we have to allow that. So let me quickly log into this 68920. That's the instance. Go to the security. As of now, this is what we have. So in my case, I'm using 8081, so I have to allow that as well. So let's go ahead. We'll edit this and 8081 from anywhere. Now I can take the server IP and access this on 8081, and I should be able to see my Tomcat here. Okay, so there's my Tomcat version 10.1.13, and the application that we are running, it's a sample application. So if I append this /sample, I should be able to see the sample application. Now, if you're not sure whether this is running on the container or not, then look at the logs. Okay, logs will tell you. You can see all this request. This is basically your logs. Now, this was for for starting the Catalina process and everything. But if you go inside the container, there are logs available. You can look at that, and this will clearly tell you. So whatever you're seeing right here, that's your containerized application that we are accessing. Just so you know. So let me stop this container. So Docker stop and the container ID. Now the container is not running. The application is also down. And if I try accessing this once again, okay, that's stopped. So now let's try it. You see, because now the container is down. Questions?
No, Ravi.
No, sir.
Okay. So that's basically how you create your custom images in Docker, and you can use that to containerize your applications, access your applications. All those things are possible. The next concept we have is a Docker Compose. Now, see, until now we have been working with one container at a time, right? Now, simply if you want to run multiple containers, you can make use of your Docker Compose. So, by just giving one command, let's say Docker Compose up, when I give that command, I want 5 containers to be up and running. I can make use of your Docker Compose for that. So Docker Compose is always used to run multiple containers using one single command. Something like, let's say you want to have a web application, and that web application needs to be connected to a database, right? So now I want a web application, I want to have a database application. For that purpose, I can make use of your Docker Compose. Docker Compose is a tool which is used for defining and running multi-container Docker application. So whenever we are talking about running multiple container applications, we make use of a Docker Compose for that. So with Compose, you use a YAML file. So under this also, we create a file. It's a YAML file, and we give the instructions to configure your application services. Then, so once you're done creating this YAML file, with a single command, you create and start all the containers from your configuration. So in this YAML file, any number of containers you have defined, with one single command, you can bring up all those containers. So you can use Compose in 3-step process. First, you can define the application's environment with a Docker file, so it can be produced anywhere. So essentially defining your custom image. Then define the services that makes up your app in the Docker Compose.yaml file. So basically the containers that you want to run. You define those containers in the YAML file, and then by using this command docker-compose yup up, you start running the entire application that you have defined in this Docker Compose YAML file. So simply, if you want to run multi-containers, you make use of your Docker Compose. Does that make sense?
Ravi.
So to begin with this, you will need to first install the Docker Compose. You don't get this by default with your Docker installation. It's an additional installation that you'll have to do. So you'll have to install Docker Compose. So to start working with your Compose, you will need to first install it, and you can make use of the below URL to get the installation instruction. So if you go to this URL, this will give the instructions that you can use to work with your Docker Compose. So let me go over here, and here you have all the instructions. So in our case, we're looking at your Linux machine, and for the Linux machine, we're looking at Ubuntu, and here I have the instructions. One moment. This is for Docker desktop. Why am I looking at Docker desktop? Okay, compose. Yeah, okay, so here we have the instructions. So this is for your Linux. Okay, so download it, apply the executable permissions, and test and validate. So it's a very straightforward steps you have. So here also you have the instructions, so you can use the same instructions. Okay, so let me download this. So first we are downloading the Docker Compose. This should download the Docker Compose for us in the user local bin path. Then we are going to set our execute permission, so we can run this particular command for that. And done. Now you can validate whether Docker Compose is running or not by using this. So Docker Compose version 2.20.3. So just 3-step command. Download the binary file, give the execute permission, check the version. That's all. So it's a very straightforward installation you have. Once you have the Docker Compose installed, you can start defining your YAML files. Okay. So YAML files, I'll show you tomorrow how you can work with that. So there are a few examples that are available. I'll show that. So here, Docker Compose. Yeah, so let's say we have this application called WordPress application. Now, WordPress application, it's a web application. So here, if you see, we have 2 containers. So this is one container. This is another container. So essentially, running multiple containers is where we make use of a Docker Compose. So we'll talk more on this tomorrow. We'll execute this. I'll also show you the application. And we'll also do the validation. And then we'll also look at the various commands that we have in your Docker Compose. And then post that, yeah, a few more things. We'll look at this tomorrow. Cool. Okay.
Okay.
Tomorrow then.
Thanks, Ravi.
Thank you, sir.
Thanks, guys. Bye-bye.
Thank you.